All right, hello everyone. Today we are going to be covering section 7.4, which is about special parallelograms. And we've been learning about parallelograms for a while now. So we learned a lot of properties about parallelograms, right? All of those properties are right here in this box in case you forgot. So opposite sides congruent, opposite sides are parallel, opposite angles are congruent. The consecutive angles, which are the ones right next to each other, those add up to 180. And then diagonals bisect each other. So these are all the things that we've been covering over the last few days. And today we are going to talk about some special parallelograms. These are some shapes that you're probably familiar with. We're just going to learn a few more properties about them, and we're going to be practicing how to classify a parallelogram the right way. So we want to make sure we know, okay, is it a rhombus? Is it a square? Is it a rectangle? Or is it just a parallelogram and none of those special cases? So we'll start with rhombus. So a rhombus is just a parallelogram with four congruent sides. So it's not a square, right? A square would have right angles, but it does have four congruent sides. So a lot of times with parallelograms, they do not have congruent sides, right? Something kind of like this, where two sides are shorter than the other two sides. But with a rhombus, all four sides are congruent. And then, of course, we have a square. So again, you're probably very familiar with these. They also have congruent sides. So technically a square is also a rhombus because it satisfies that definition, but it has to have four right angles. So that's what makes a square a square. So it needs four congruent sides and four right angles. And then for rectangles, the congruent sides does not have to be a thing, right? So these two sides are definitely not congruent to these two sides. So the only thing that needs to happen for a rectangle is that it has four right angles, okay? Now technically a square is all three of these things, right? Because it has four right angles, so it satisfies rectangle definition. It has four congruent sides, so it satisfies this. So a square is just kind of a special case where it satisfies all three. So down here, we are going to look at a couple examples. Oh, and one thing to point out too, because these are all parallelograms, that means that all of the other properties still apply, right? So if you're ever asked to find missing angles or missing sides, you can still use all the same properties that we've been using before because these are still technically parallelograms. But now we just have some new properties that we'll be able to use. Okay, so in these first examples, we are just going to decide whether this statement is always true or sometimes true. And this is specifically about a rhombus. So for any rhombus, QRST, decide whether the statement is always or sometimes true. So it's helpful to draw a diagram for this. So because of the way it's named, QRST, you just want to make sure you label your diagram in that order. It doesn't really matter where you start from. You just have to go in like a clockwise order. So QRST. This isn't the best diagram, but let's just pretend that this is a rhombus. So that would mean that all four sides have to be congruent. So we're going to decide whether this is always true or sometimes true. Angle Q is congruent to angle S. So that would be this angle here and this angle here. Because this is a parallelogram, those angles would absolutely have to be congruent. It doesn't matter that this is a rhombus, they're still congruent because this is a parallelogram. So this one would be always true. And then as far as explaining our reasoning, I will say that that covers the parallelogram opposite angles theorem. That's something we learned before, right? That theorem says that opposite angles will always be congruent. So for the next one, angle Q is congruent to angle R. I think I'm just going to use the same diagram. I'm just going to go over here. If you want to draw a new diagram, that's fine. But let's take a look at that one. So they're saying angle Q would need to be congruent to angle R, right? Now that's not always true in a rhombus. Now, what we do know is always true is that these two angles would have to equal 180 if you add them together, right? If you look at the picture that I drew here, it's very clear that those two angles are not the same, right? Like one of them looks like an acute angle, the other one looks like an obtuse angle. So if it's just any old rhombus, these are not necessarily going to be congruent. However, there is a case where it would work. So I'll draw that over here. If the rhombus was also a square, right? Because technically squares, they do qualify as a rhombus. then this would be true, right? Because then you would have a 90-degree angle here, a 90-degree angle here. They still add up to 180, but they're also congruent. So for this one, I'm just going to say sometimes, because it's not always true. It would have to be a square in order for that to be true, right? And then as far as explaining the reasoning, you could just say only if the rhombus is a square. And it, you know, if the problem asked for a theorem, you could throw in something about the consecutive angles theorem. Consecutive angles add to 180. So both would have to equal 90. You're not always going to have to explain this much. I'm just giving you some tips for how to do this if it was something that comes up on a quiz. Okay, so again, same thing here, except now we're going to do this with a rectangle. So we're going to decide if these are always true or sometimes true. So I'm going to draw a diagram. This one's labeled A, B, C, D. So again, doesn't matter where you start, just make sure you go in clockwise order. And the first one says AB is equal to BC. So they're asking if that's always or sometimes. And that would only be sometimes, right? So the definition of a rectangle is just that there has to be 90-degree angles. These two sides here, they don't necessarily have to be congruent. Now the opposite sides do, but not these two, right? But there is one case where it would work. It would work if it was a square, because technically squares are also rectangles, and that would satisfy this picture, right? So we'll say sometimes. And then again, I'm just going to say if it's a square. Okay, and then let's do this one over here. I'm just going to draw a new picture because my other one is a little messy. So A, B, C, D, and then AB is equal to CD. This would be always, right? Because in rectangles, those opposite sides are equal. And that's actually true for any parallelogram. Since this is technically a parallelogram, opposite sides have to be equal. So I will say the parallelogram opposite sides theorem. Rhombus and a rectangle, just to go back to this page. A square satisfies properties for both rhombus and rectangle because it has those 4 congruent sides. It also has those 4 congruent angles. Okay, so on this next page, there are some you try problems. If I was in class right now, I would normally have you try these on your own before I just show the answers. If you're watching from home, you're welcome to pause the video and you can try them yourself. But for the sake of this video, I'm just going to keep going here. So for any square, let's do this first one. For any square JKLM, so JKLM, is it always or sometimes true that JK is perpendicular to KL? So let's look at that picture. JK and KL, that would be this right here. So they're saying, is it always or sometimes true that that would be a 90-degree angle? And then since this is a square, that would have to always be true, right? Because that is literally the definition of a square. Squares have to have 4 right angles, and they have to have 4 congruent sides. So we'll say always. And for the reasoning, I'm just going to say definition of square. The next one is about a rectangle. So let's make a rectangle. E, F, G, H. Is it always or sometimes true that FG, which is this side here, is congruent to GH? And we've already talked about this one on the other page, right? This is sometimes true. So those two sides are not necessarily going to be congruent, only if it's a square. So I'll say sometimes if it's a square. Okay, and this last example here, this is a little different. So it's giving you some descriptions about a quadrilateral, and it's asking for us to sketch it and then classify it. So remember, a quadrilateral is just a 4-sided shape. So it says a quadrilateral has 4 congruent sides and 4 congruent angles. We have to figure out what kind of quadrilateral it is. I'm going to start with the angles because sides could be 2 different things, right? If it satisfies this, it has to either be a rhombus or a square. But the angles, if it has 4 angles that are congruent, remember quadrilaterals have to add up to 360. We learned that a while ago. So if you take 360 and just divide it by 4, that gives us 90 degrees. So that means this shape would have to have all right angles. So it has to be a square, right? So we would classify this as a square. Okay, now we're going to learn some more specific theorems about each of these three shapes. So we've got the basics down, we learned the definitions of them, and now we're going to learn some more theorems about them. And we'll start with a rhombus. The first theorem is called the rhombus diagonals theorem. Now, we already know that in a parallelogram, the diagonals will bisect each other. That's also true for a rhombus, right? But this theorem is a little different. This one is only specific to a rhombus. So it says a parallelogram is a rhombus if and only if its diagonals are perpendicular. So that's just something that happens with a rhombus. If all sides are equal here, it's going to create a situation where the diagonals kind of lock in this perfect right angle. So that will always be true within a rhombus. It's not necessarily true for every parallelogram, though. It's only true if it's a rhombus. So diagonals perpendicular if it's a rhombus. It's going to make a 90-degree angle there. And then we also have something called the rhombus opposite angles theorem. And it says a rhombus if the diagonal bisects a pair of opposite angles. So looking at this picture here, this diagonal is bisecting the angles, right? So like this piece equals this piece. So if this was 20, this would also be 20. And then the same thing is happening over here, right? This piece is going to equal this piece. And that's because a rhombus, it has some symmetry, right? Because it's got those 4 equal sides. So the diagonals bisect each other, or bisect the angles. In other parallelograms, that's not always true. And that's actually something that some of you guys struggled with, especially on that last quiz. Like if this was a parallelogram, but not a rhombus, if this was 14 degrees, that does not mean that this is 14 degrees, right? You can kind of tell by looking at them. They don't equal each other. So that's only true if all 4 sides are equal in a rhombus. Okay, so in this example, we're just going to find some missing measurements using all of those properties we just talked about. So it says find the measures of the numbered angles. So let's take a look at this. Let's start with angle 1. Angle 1 is right where the diagonals meet each other. That has to be 90 degrees because the diagonals are perpendicular. That's using that diagonals theorem. So the measure of angle 1 is 90 degrees. And then let's take a look at the measure of angle 2. So the measure of angle 2 is... So that is over here. Now, because this is a parallelogram, it's also a rhombus, but in a parallelogram, opposite angles are equal. And also, because it's a rhombus, these little pieces here will equal each other because the diagonals are bisecting the angle. So that means this is 61. It also means these are 61. Because remember, opposite angles have to equal each other, right? So the measure of angle 2 and angle 3 would both have to be 61 degrees. So I'm just going to put angle 3 also. And then now we have to work on finding the measure of angle 4. So that one's going to take a little bit of work, but not much. There's actually a couple different ways you could go about doing this. So you could use the fact that consecutive angles, I'm going to erase this for a second. You could use the fact that consecutive angles add up to 180, right? So if this whole thing is 61 plus 61, that would be 122. That means that this whole thing down here would have to be supplementary to that. So what you could do is just do 180 minus 122, and that would get you the measure of this angle down here. So that would be 58 degrees, right? But remember, that's the whole angle. So if you wanted angle 4, you would just have to split that in half. So that means each of these would be 29. But I'll show you another way to do it too. Another way to do this would be to use the fact that this triangle right here, that is a right triangle. Because remember, angle 1 was 90 degrees. So if we know that this angle up here, remember this was 61, if this is 61 and this is 90, you could find angle 4 pretty quickly. You could just, because, you know, in triangles, all these have to add up to 180. So you could just do 90 take away 61, and that would leave you with 29 as well. So the measure of angle 4 is 29 degrees. Okay, so here's a few more you try problems. Again, if you're watching from home, you can go ahead and try those on your own, or I'm just going to continue going along here. Some of these we've already figured out. It says find the measure of angle ABC. That is this corner over here. That's this whole thing. We actually already found that out, right? That was 58 degrees because it's 29 plus 29. So this one would be 58 degrees. And then the measure of angle ACB. So ACB, that's this piece right here. That would have to be 61 because it's equal to the same thing because the diagonals bisect the angles. And then if we're looking at ADC, we already found that, right? That's that 29 plus 29, so that's 58 also. And then for BCD, that would just be 61 plus 61, so 122 degrees. Okay, and then this last example here, it says find the measures of the numbered angles in this rhombus. So let's take a look at that picture and see what we can figure out. So the way I typically like to do this, I just kind of look at the picture and start labeling some things. If this is 118, we know this is 118. Now we have no other information about these angles, right? So I would use what we know about parallelograms. So we know that consecutive angles, so this whole entire angle here, 3 and 4 together, that has to make 180 with 118. So I would start by just doing 180 minus 118, and that is 62. So that means this whole section down here, this whole angle has to be 62. And since this is a rhombus, that means this diagonal is splitting that in half. So each of those pieces would have to be 31 degrees. Same thing on the other side, right? This would also be 31. So that means all 4 of those angles are the same measurement. They all equal 31 degrees. So I'm just going to say all angles equal 31 degrees. Okay, let's go ahead and move on to the next page. Rhombus, the diagonals will be perpendicular. Now, if it's both of those things, it's actually both. Okay, so this theorem is specific to rectangles only, and it's also about the diagonals, right? So in rhombuses, the diagonals are perpendicular. That's what we learned about a rhombus. In rectangles, they are not going to be perpendicular. You can kind of tell just by looking at this, right? Like this definitely does not look like a right angle. But what will happen is that they will equal each other. So this and the length of this entire diagonal is going to be identical to the length of this entire diagonal. They also still bisect each other because remember, that's any parallelogram. Any parallelogram, they still bisect each other. That means this is still a midpoint, but the length of them is going to be the same now. So that means all 4 of these pieces will be equal. So let's take a look at this. Now, as long as it satisfies that, by the way, so let's say you know nothing else about the shape, and the only thing that you know is the diagonals are congruent. That is enough to say that it's a rectangle. That's going to be useful later on. So in this first example, it says, can you conclude that the figure is a rectangle? And what they're showing us here is that the opposite sides are equal. Now, I know it looks like a rectangle, but that's actually not enough information to say that this is a rectangle, because the definition of rectangle is that it has 4 right angles. That's the only way to prove that this is a rectangle. Like this could actually be a parallelogram. It could be something where it's like slightly off and it would still satisfy this 44, 44, and 33, 33, right? And that's definitely not a rectangle. So even though it looks like one, we can't assume that these are 90-degree angles unless they give us that information. So we're going to say no for this. So no. And then as far as the explanation, I will say the definition of rectangle is 4 right angles. And then we have no info about the angles here, right? So we have no info about angles. Okay, the next example, they give us a diagram and then they give us some information here. So it says QS is 5x minus 31. That's a diagonal. It's kind of hard to label. I'm just going to go like this, 5x minus 31. And then RT, that's another diagonal, so that's this one. That one is 2x plus 11. and they want you to find the length of the diagonals. So I would start by figuring out what x is, because once we know what x is, we could plug it back in to get the length. And since this is a rectangle, they're telling you right here it's a rectangle, that means diagonals have to be congruent. So you would just set these two equal to each other. So 5x minus 31 equals 2x plus 11. And then let's quickly solve this. If I move the 2x over, I would get 3x. And if I move that negative 31 over, I would get 42. And then once we divide, we get x equals 14. And then once you have the x, you can just plug that back in. You can plug it into either diagonal, either one is fine. I tend to just pick the one that looks easier. I'm gonna do the 2x plus 11. So 2 times 14 plus 11, that would be 28 plus 11, which is 39. Now, just to be safe, if you wanted to, you could plug it into the other one just to make sure. If you were taking a test or a quiz, I would absolutely do that, right? Just do 5 times 14 and then take away 31. Make sure that also equals 39, right? And it does. Okay, I think I'm going to skip this you try. It's pretty much the same thing. If you're working from home, feel free to solve it. If you want to try it yourself, here's what the final answer should be. X equals 8, and then the length of the diagonals should be 41. But it's pretty much the same thing. You're just setting these equal and solving. Okay, finally, we are going to talk about how to classify parallelograms in the coordinate plane. And there's a lot of different ways that you could do this. So remember, with coordinate plane, we've done some of this with parallelograms. For example, on your most recent quiz, there were things where you had to like prove that the shape was a parallelogram by finding slopes and distances and stuff like that, right? So this is very similar to that, but I'm going to give you some shortcuts for how to make this go as fast as possible. So the easiest way to go about doing this is to use the diagonals, because there are some very specific theorems in each of these shapes about the diagonals. And let's just review those real quick. So if it's a rectangle, the diagonals will be congruent, right? If it's going to be a square, because remember, a square is, in a square, the diagonals will both be congruent and they will also be perpendicular. So the easiest way to do this is to just use the diagonals, because that only involves 2 side lengths, right? That means you don't have to find the measure of all 4 sides. I mean, you could definitely do that if you want to. If I asked you to classify a rectangle, like prove to me that this thing is a rectangle, the long way to do that would be to prove that all of these corners are right angles. And that would involve doing a bunch of slopes, right? And after you do a bunch of slopes, you would still have to find the distances here to prove that the sides are not all equal. So that's kind of a lot of work. So again, the easiest way to do this is to only focus on those diagonals, because that's actually enough information to classify the shape very specifically. So the first thing I would do is test to see if it's a rectangle. If it's a rectangle, that means the diagonals have to equal each other. So I would start by finding the length. So find the length of both diagonals. And this is going to involve the distance formula. Remember, anytime we find length, it involves distance formula. I like to call this the rectangle test. You'll see that on the next page in a second. This is the rectangle test, because if the diagonals are congruent, if their lengths are congruent, it's definitely a rectangle, okay? But you do have to keep going. So let's say you find the length of the diagonals and you notice that they're congruent, and you can say, oh yeah, that's a rectangle. You have to keep going because you want to classify it the most specific way possible, because even if it's a rectangle, it might also be a square. So you want to find out if it's a square too. And in order to do that, squares are going to have perpendicular diagonals, because a square is a rhombus, right? A rhombus has perpendicular diagonals. So the next step would be to find the slopes. So find the slopes of both diagonals. And you're looking for opposite reciprocals if you do that, because that's what creates perpendicular slopes. So if you need a reminder of what that looks like, something like 2/3 and negative 3 over 2. You want those slopes to be completely opposite. So if you notice that you have opposite reciprocal slopes, that means you have right angles, and that means it is a square or rhombus, right? So I like to call this the rhombus test. So once you do these things, let's say it passes the rectangle test, but it fails the rhombus test. That means it's just a rectangle. Let's say it fails the rectangle test, but it passes the rhombus test. That means it's a rhombus. But if it satisfies both of these, that means it has to be a square, because that's what a square is. A square is technically just both of these things combined, okay? So we're gonna practice on the next page. This will make more sense once you start to do it, but that's the best way to go about doing this. I would absolutely just focus on the diagonals. You don't need to focus on anything else, just the diagonals. Do distance twice, and then you're gonna do slopes twice to see if they're opposite reciprocals, okay? So let's go to that next page and practice. Okay, so here is our first example. The first thing we're going to do is just plot those 4 points. So we're deciding whether this parallelogram is a rectangle, a rhombus, or a square, and it says give all names that apply. So let's plot the shape first, and then we'll practice finding out those things. So A is at negative 2, 6. B is at 6, 8. C is at 4, 0. And D is negative 4, negative 2. Okay, so here's our shape. Okay, so it clearly does not look like a rectangle or a square, right? We still have to show all of the work to prove that, though. So even though it looks like it's not a square or a rectangle, I still want you showing all of the work to prove it. So the first thing I am going to do is the rectangle test. So I'm going to say rectangle test here. I just like to call it that. The rectangle test would be if the diagonals are congruent, which means same length, right? So this involves distance formula. And we're only going to focus on the diagonals. So we're going to do A to C and then D to B. So we're just going to do 2 little distance formulas. So I'm going to start with AC. And distance formula, remember, I like to do the shortcut method. Some people do the whole distance formula. I just take a look at the coordinates from A and C, and I just calculate those distances kind of in my head. So to get from negative 2 to positive 4, that's a difference of 6. So that would be 6 squared. And then to get from 6 to 0, that's also a difference of 6. So 6 squared plus 6 squared. So that's 36 plus 36. So that would be, oops, the square root of, not 36, 72. And you don't have to actually square root it if you don't want to. Okay, now let's do dB. Same process here. So I'm just going to calculate those distances. So to get from D to B, let's see, the difference between 6 and negative 4, that's 10. So 10 squared plus, and then from 8 to negative 2, that's also 10. So that would be the square root of 200. So they're definitely not the same, right? So that means that this is not a rectangle. So now we are going to do the rhombus test. So if it was a rhombus, then this right here would have to be a 90-degree angle. Now let's say it fails the rhombus test. If it fails the rhombus test, that means this thing is just a parallelogram. It's not any one of these 3 things. We would just say parallelogram, right? It's looking like it's probably going to be a rhombus, but here's how you prove that. So now you're going to find slopes of the diagonals. So same 2 sides. You're still doing AC and DB. I should have said B over here. Okay, so let's do our slopes real quick. Remember, slope is just y2 minus y1 over x2 minus x1. Okay, so let's do the slope of AC. So we have 0 minus 6 over 4 minus negative 2, which would give us negative 6 over 6, which is negative 1. And now let's find the slope of DB. So looking at the coordinates for D and B, we would have negative 2 minus 8 over negative 4 minus 6. and that is negative 10 over negative 10, which is positive 1. So remember, we're looking for perpendicular slopes here. Negative 1 and positive 1, those are perpendicular because it's kind of a, an easy fraction where it's just 1 over 1. So when you flip this upside down, it's still 1 over 1 and it's negative positive. So because those are perpendicular, this passes the rhombus test. And now we have to classify the shape. The best name for this shape would just be a rhombus. It's definitely not a rectangle, right? Because it doesn't have those congruent diagonals, which means there's no right angles here, so it can't be a square either. It's just a rhombus. Okay, now we're going to do the next one. Same thing here. So we can go ahead and graph the shape. You can go ahead and do that, and then we're going to do those same two tests to see what kind of shape this is. So here we go. We have negative 5, 2. That's P. 0, 4 is Q. 2, negative 1. And then S is at negative 3, negative 3. Okay, so here's what the shape looks like. And we're going to do those same two tests. So remember, we're just using the diagonals here. So I'm going to use PR and QS. So let's start with the rectangle test. This is the one where you use distance formula because you're trying to show if the diagonals are congruent. So we're doing diagonals here. So that would be PR and QS. So I'm going to start with PR. Okay, so for P and R, just looking at those coordinates, the distance between negative 5 and 2, that's 7. So 7 squared. And then the distance between 2 and negative 1 is 3. So we got 7 squared plus 3 squared. That'd be 49 plus 9. So the square root of 58. Okay, now we're going to do QS. Same process here. So looking at Q and S, if I'm going from 0 to negative 3, that's 3. And then 4 to negative 3 is 7. So that is going to be the same thing, right? 3 squared plus 7 squared. So that's the square root of 58. So that means this passes the rectangle test. And all that means, remember, definition of rectangle is 4 right angles. So that's all that means. It means these are all right angles. So now let's go ahead and do the rhombus test. So the rhombus test is basically going to tell us if it's a square also, right? And it looks like it's probably going to be a square, but we're going to show the work to prove it. So the rhombus test involves slope, and we're using these same two sides here. So I'm just going to go like this. So for the slope of PR, we are going to do y2 minus y1. So it'd be negative 1 minus 2 over 2 minus negative 5. So that would be negative 3 over 7, because this turns to a plus down here. Okay, so there's the first slope. And then the slope of QS, so let's see, it would be negative 3 minus 4 over negative 3 minus 0. So that's negative 7 over negative 3, which turns positive. So that's positive 7 over 3. And if you compare those two slopes, those are definitely opposite reciprocals. So that means they're perpendicular, which means it passes the rhombus test. So if it passes both of these, that means it's a square. It's technically all three of these shapes, right? The most specific name for it would be square, but because it says give all names that apply, it's actually all three. So I'm just going to write all three. So it's a rectangle, it's a rhombus, and it is a square. All right, and that is it for the notes. So now you can start the homework.